All right, guys, on page 56 of your notes, we're going to talk candy because who doesn't love candy? So they want us to organize the following candy into this Venn diagram. They want us to order the Snickers, the Hershey's chocolate bar, Mars bar, Laffy Taffy, and Starburst. So overall, we can agree that all of these are different types of candy, right? So now we need to think about bars. Well, which of these are bars? Well, we know that a Snickers bar, a Hershey's bar, and a chocolate bar all would go in this bars category because they're all bars. Well, so is the Mars bar. What about taffy like? Well, taffy like would be Laffy Taffy and Starburst because those are both taffy like. Okay, so we have these two gone. Now, Snickers, Hershey chocolate bar, and Mars bar are all different types of bars. They're all chocolate. Okay, they all do not have caramel. So right here, a Hershey's chocolate bar would stay here in this circle because it does not have caramel. Okay, so we have Hershey's chocolate bar. Now a Mars bar and a Snickers still go forward. A Mars bar has caramel, but it does not have nuts. Mars bar and a Snickers would go here because it contains nuts. So we can categorize our candy. We can categorize different types of food and different articles of clothing. Well, we can also categorize our numbers and the number system. So list the set of numbers we have learned about so far, including equivalent forms. Well, you know whole numbers, you know fractions, you know decimals. Ooh. And we just talked about terminating decimals, terminating and repeating decimals. Okay. And we've also talked about natural numbers. So, because of this, are all numbers rational? Are there numbers that cannot be written as a quotient of two integers? Okay. So, what about the square root of 2? Can you write the square root of 2 as a fraction? Why or why not? For this one, the decimal, when you type this in a calculator, is too long. Okay, there's no real pattern to it either. So they say here, numbers like the square root of 2, which do not have terminating or repeating decimal expansion, are irrational numbers. So if you have something that's in the square root box and it does not simplify to a whole number, or it's not a perfect square, and it doesn't terminate or repeat decimal, it's called an irrational number. Irrational numbers cannot be expressed as a quotient. Rational and irrational numbers together form a set of real numbers. You're going to want to put a star with that. Real numbers can be thought of as points on an infinitely long line called a number line. Just like we organize the candy bars in the Venn diagram above, we can organize the real number system. So go ahead and draw this with me. All right, we have a box. And in this box is our real number system. So numbers on our number line can either be irrational or rational. And on the previous page, we talked about what irrational means. And inside of that rational and irrational box, a number that's rational, A, can then be put into integers. Sometimes. Integers. And from integers, we have numbers. So anything that is in this box is a rational number. Whole numbers are rational numbers. Whole numbers are also integers. Just like above where we had this nuts, Snickers is also a Mars bar. Okay, that is chocolate, and it's a bar, and it's candy. Just like that, we can have whole numbers that are integers, rational numbers, and they're a real number. Okay, so looking at this graph, I always like to work right from left. And the reason why is because we know every single number on here is a real number. We know that because numbers are either rational or irrational. Well, since those are all real numbers, the second thing we need to consider is, okay, are they rational or irrational? And this is going to be on your test. Anytime a number, okay, can be written or simplified, it's a rational number. Now, the square root of 5 is going to be irrational because when you type the square root of 5 in the calculator, it doesn't come out to be a whole number. It doesn't come out to be a pretty number. The decimals do not repeat and the decimals do not terminate. So it's irrational, okay? The other one in here that's irrational is the square root of 10 for the same reason. Okay, 10 is a whole number, which we'll get to in a minute. 0, okay. Now I might be saying, well, Ms. Swiderski, why isn't the square root of 36 an irrational number? Well, when you type in the square root of 36 in the calculator, that simplifies to 6. We know that's a rational number. Same with the square root of negative 121. That's negative 11. Okay. 2.5, great. This one's a repeating decimal, so it's rational. So, integer, all right? Numbers that are integers, okay, look like this. So we're going to have negative 2 as an integer, 10 and 0 are integers. Okay, square root of 36 is an integer, square root of negative 121. And then whole numbers are going to be 10, 0, and the square root of 36. Okay, so let's look at number 1. Number 1, well, this is a fraction. So we know it's a rational number. Okay, the second one, it's a decimal with terminating number, or terminating fraction. Sorry, terminating decimal. Number 3, it's negative, and it can be put into a fraction. Number 4, okay, it's not a perfect square, which means it's going to be irrational, okay? Number 5, left blank. Number 6, left blank. Number 7, okay, is irrational because it's also not a perfect square. Not a pretty number. 8, number 8, I said it's a perfect square, which gave me a whole number. 9, it's a fraction. 10, oh, sorry, 11, number is repeating decimal, and it can be put in as a fraction. So number can be put as, number is repeating decimal, but it can be put into fraction form if need be, okay? So I know some of these are tricky, but what I want you to do is to go ahead and try page 59 on your own. When you are done, call me over and we will go ahead and go over it together.